Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Well, guys, before discussing the acceleration of the freely falling body, as I told you that today we'll also try to learn that how to find out the diameter of a wire without the use of this micro screw gauge. We'll find out the diameter of this wire using this ruler, or meter rule can also be used. You can see that I have wrapped this wire around this ruler. Now there are how many wrapping? Let us count these number of turns which I have shown here. There are 1, 2, 3, 4, 5, 6, 7. Now I have total 7 number of turns. Now we are going to find out the diameter of this wire using this ruler. Actually, I am finding it very difficult to handle it, so it will be a rough calculation basically. So here you can see that from the very beginning, I am just pressing this wire like this, and then I'll see that what is the millimeter, which if you can read it, I'll try to bring in focus. The lower reading you can read, it is almost, if it is visible enough, 0.7 millimeter. Okay, well, just wait. I'm placing it at the mark of 3 millimeter, 3 centimeter, and then after 3 centimeter, actually it is very difficult to handle it like this. I am placing nose plus here. Try to read. Just let me bring it in focus. You can read the low reading. It is 0.7 something. I think so, 0.7 something. This is the reading. 0.78 or 0.7 something. Obviously, whatever you have to do, actually, the number of turns were also 7, or it was 0.78. 0.78 was divided by number of turns. So diameter will be 0.11 millimeter. It means in two decimal place, its diameter will be 0.11 millimeter, because the total number of turns of the wires were 7. Now let us find out the diameter of the same wire with the help of this vernier micro screw gauge. Although there is a zero error in this micro screw gauge, because you know that we also have to discuss that what is a zero error. I'll explain that zero error too. So here you can see that how I am going to find out the diameter of this wire with the help of this ruler. First of all, I wrap this wire around this ruler, and then I am pressing it hard so that each turn must be closer to each other. Actually, I'm finding it very hard to press it like this. If I start it from 1 centimeter mark, if the starting mark is 1 centimeter, this type of experiments need to be very carefully done. I'm roughly doing it. Now here, if you can read that, this is almost 0 point. Now you can read the reading, because the starting point is 1. Okay. You can read, see, because, okay, 0.7. Well, it means if it is 0.7 centimeter, 0.7 centimeter, or in millimeter, you can see, for example, there are 7 millimeter. So you mean to say that that the diameter of this wire is 1 millimeter, you mean to say. Now let us see with the help of this micro screw gauge. That is why this micro screw gauge is used. Actually, as I told you that this micro screw gauge had developed some zero error in it, and its visibility due to the reflection of the light is not very uh, accurate. Well, let me insert this wire in my micro screw gauge. Now I am going to take the reading with the help of the ratchet. Just wait. Let me take it out like this. I am placing it here. Now, with the help of the ratchet, I have tightened it. I am bringing this in focus. Okay. Just wait. Let it be clear and then you will tell me the reading. What is the main scale reading? Well, now I think so it is clear. The main scale reading is 1 millimeter, okay, 1 millimeter, and the Vernier scale reading is almost 29. Okay, the main scale reading is 1 millimeter because the mark of 1 millimeter can be seen very clearly under this edge. Okay, this 1 millimeter mark can be seen. So the main scale reading is 1 millimeter. Main scale reading is equal to 1 millimeter, and the the circular scale reading is 29. Let me bring it in focus. 29, as you know that you have to multiply it with the least count, which is 0.01 millimeter. This will be 0.29 millimeter. So total will be 1 plus 0.29, 1.29 millimeter. So this is the diameter of this wire, 1.29 millimeter. Actually, there was also a zero error in this instrument because there is some error. What that error was, we will discuss in detail the same thing. Now, please observe that what is the zero error here in this instrument. When I am closing this instrument like this, you can see that after closing, when this I have turned it off completely, you can see that 40 something has come here. Actually, what it should be? It should be here. But I am finding that I can turn it more. If this instrument do not have any don't have any zero error, then this zero of the circular scale must coincide the index line of the main scale. But it is not happening like this. If I am turning it gently, it can be turned further. Now you will have to see that how many marks it has passed. Now you can see this 5 and then 10 and almost 12 something. It has passed 12 grades. So basically its zero error is a positive, its zero error is, in this zero error we have to subtract something because this is a positive zero error, and whenever there is positive zero error we have to subtract that much reading from it. As you know that we have taken the reading of the wire 1.29 because it was a positive zero error, and it will be discussed in detail. We have to subtract 0.12 from here. I'll tell you in detail that what is the positive zero error. So its correct reading may be 1.17. This is a rough calculation. Well, now let us move to the